Hey y'all, welcome back to another 2-Min Maths video. I'm super excited to be talking about continuous compound interest. And this is some of the lessons in math class where you learn and you can actually use it on a day-to-day basis, which is pretty cool. So this is the equation for a continuously compounded interest formula, where A is considered the final amount, P is considered the initial or the principal amount, as some word problems may state, E is that special term, and R is the interest rate, and T is time. Now let's do some fun word problems. Let's look at an example. $1,000 is deposited into an account paying 6.25% interest compounded continuously. Now this tells you that we're using A equals PERT. That's just a shortcut of understanding and memorizing this equation. How long will it take to double? Round to the nearest year. So, as I mentioned, A equals PERT. You can memorize it as like PERT, PERT. Really easy, honestly, to remember our formula. And we're going to set our final amount, which is double of our initial deposit, which is 2,000 equals 1,000 e to the power of 0.0625t. Now, some things I see students make mistakes on is they plug in 6.25 for R, but remember, this is a percentage. You want to write it in decimal form, and 6.25% decimal form is 0.0625t. And that's just me plugging in the values from the word problem into our PERT formula. And now we can divide both sides by 1,000 and we get the following. And after that, we can take the natural log of both sides to get rid of that e, because we know that natural log of e is equal to 1. A really handy tool when it comes to these sort of problems. And we get, after isolating t, natural log of 2 divided by 0.0625. Try not to round or approximate these values during the process, but instead use the exact values, such as natural log of 2, and then approximate to the very end. So we get that t is equivalent to around 11.09, which rounding to the nearest year, aka we have to round up because technically it will not double at 11 years. It will double the year after, which is 12. So it'll take 12 years to double the deposited amount. Make sure to write your answer in a complete sentence. And note that it doesn't matter what the principal amount is, the ratio will always be 2. So if you're given a problem similar to this, except that you weren't given the initial amount, that doesn't matter, because if you're finding how long it'll take to double, that ratio will still equal 2. The interest rate is, of course, that's going to be different depending on what rate you're given, but if it's saying double, the initial amount doesn't matter. Hope this video helped. Comment down below any of my topics from your review. Thank you.